Hello. Let's see down, do this a little bit right here. I hope you can see this thing. Anyway, the next subject that we're going to talk about is the nervous system. Okay? So we'll probably cover this in about 3 lectures. Probably get it out to you this week, probably do the end of next week or something like that. So probably by the end of the first week, first full week in April, whatever the date that is, maybe right up toward Easter. I don't know, we'll see, I have to see how it goes. Now, the nervous system is made up of billions of cells, all right? I don't know the number. If we have a question on there, we'll write down the word billions in a few minutes, okay? But each cell has the same name. It's called a neuron. The neuron is a single cell of the single functional unit of the nervous system. So the first objective is to draw and label a neuron. Now, you got to name it first. You got to name it and then draw it, okay? Name it a neuron, and N-E-U-R-O-N. Now I'm going to draw it up here. If you can't draw it in your answer, just list the parts for it, and that'll be fine with me, okay? Some of you can and some of you can't have the ability to draw the thing, but that's all right. I got to draw you one, all right? Kind of looks like a sperm with feelers on it, doesn't it? If you can remember back that far. And I know you can, okay? So if you can't draw the thing, let's label it, okay? Label it from one end to the other, okay? Now, when these things were first looked at, I think there was a silver stain that was looked at. And a guy that looked at it says, man, these things look like branches on a tree. And the name dendrite came into being. So these feelers on this end right here are called dendrites, D-E-N-D-R-I-T-E. Remember, this is a neuron, N-E-U-R-O-N. Dendrite, D-E-N-D-R-I-T-E. These are the dendrites. Okay, this is the cell body. Happy looking D right there. Well, I can't make a D, but I can't. Anyway, that's the cell body. Now, this long film right here is the axon, A-X-O-N. Axon. And these filaments down here at this other end right here look like the filaments on the other end, look like dendrites. But we can't use the word dendrite because that would be confusing. So we call these telodendria, T-E-L-O-D-E-N-D-R-I-A. Okay? Telodendria. Now there's one other thing I want you to put on here. Between the cell body and the axon is a region here called the axon hillock. A-X-O-N-H-I-L-L-O-C-K. Axon hillock. So your objective is name and draw, name and label if you can't draw the thing. And I'd like for it to be from a dendrite to the telodendria, okay? So just, if you can't draw it again, just label the parts to it and I'll be happy with that. Now, how many neurons were you thought to have had? Billions is the answer. I don't know how many billions that we got right there, okay? Most are not functional at all, especially the ones in our brain. I think we'll probably only use 13%, 10%, 8%, somewhere in there of the neurons in our brain. The rest of them are just mass. So how many do we have? Thought to have billions. Now let me show you an organization of the neurons. My organization, you won't find this anywhere else, but it makes sense to me. I'm going to erase this thing right here. Erase my neuron. That's question number 1. Didn't put the label 1, but I figure you'll get the sheet and you'll figure that out. Okay? So, I'm going to label them. I'm going to try to separate these as far as location. Location. Now, I'm going to put 2 areas up here where we find them, okay? We find them in the central nervous system, that's the brain and the cord, or we find them outside the brain and the cord called the peripheral nervous system. CNS for central nervous system, PNS for peripheral. You can abbreviate just like I'm going to if you want to. CNS, PNS. Central nervous system, peripheral nervous system. Again, the central nervous system is the brain and the cord. The peripheral nervous system is the neurons outside the brain and the cord. Now, that's just where they are. Function. Function. Now, I don't really care I'm gonna give you two functions right here. One is sensory, one is motor, and I don't really care where that it goes, under sensor or peripheral. It doesn't really matter about that. The vertical organization is not important where this thing goes over here. The horizontal, the fact that you know the two divisions is, okay? So as far as function right here, sensory, S-E-N-S-O-R-Y, motor. Motor, that's an R. Looks like an N, doesn't it? There it is an N. Motor. Now what this is where do these sensations go? They either go to the cord when you feel something. That's a sensory input. When you move a muscle, that's a motor input. That's the difference between them. Now, so here are two differences between location, function right here. Regulation, control. I'm going to put down control or regulation. Regulation is fine if you like that word better. Control. This is question number 2. Let me be sure it's number 2. Okay, now control. Whenever we move something, that's a conscious control. Conscious. It's called the somatic nervous system. I don't need that. That's a conscious motor control right there. I'm going to write down conscious, and then some things are automatic. Subconscious. Not unconscious, subconscious. Conscious. C-O-N-S-C-I-O-U-S, conscious. Subconscious. Conscious and subconscious. So those are 3 ways that we can recognize these. Kind of organize the billions of neurons that we have, okay? Hey, like that billion. Well, what the hell, it is for emphasis. Now, I want to draw and label the signal that this sucker produces. But I got to introduce you to the concept first. So hang in here with me just a few seconds. I'll get about 5 or 6 covered. I'll take a little break and I'll come back and cover the rest of it. I'll finish it tomorrow. Okay? Now, this really soft chalk up here. You want to grab that. Ordered some hard chalk just for y'all. Well, just for the people I lecture to anyway. Now, name and draw the signal that the neuron generates. The name of it is the action potential. Action potential, 2 words. Question number 3. A-C-T-I-O-N, P-O-T-E-N-T-I-L, action potential. But first, I got to have another part of this question right here. I got to have you define potential difference. PD, potential difference. We got to do this before we get into the action potential, what the function of the action potential is anyway. Potential difference. So I'll probably just make this part of that same question for you to define potential difference. Potential difference. P-O-T-E-N-T-I-L, P-O-T-E-N-T-I-L, difference. Now, to define this, it's a difference in charges inside the cell versus outside the cell. Again, it's a difference of charges inside the cell versus outside the cell. Now, let me show you a potential difference right here. This is a cell. That's a cation. That's a positive charge right here. You put a cation on the outside. In this example, there's no potential difference. The charges are the same. It doesn't matter how many pluses I put inside. So I'm going to put the same number of pluses on the outside. There's no potential difference. So potential difference drives the movement of the ions. It drives the movement of the ions. Now, our cells are kind of like this right here, with sodium on the outside, potassium on the inside. I'm going to go ahead and label this right here. Sodium and potassium right here. Sodium, potassium, Na and K, sodium and potassium. Okay. Now, if that was all there was to it right there, there'd be no driving force for these ions across the cell membrane at all. There would be no action potential, and our nervous system, our neurons, wouldn't function at all. But what we do find is there's a negative charge inside this cell, a negative charge inside this cell. The negative charge inside the cell is due to negative ions called anions that are trapped on proteins that cannot get out of the cell. So our cells have a negative resting membrane potential. Our cells have a negative resting membrane potential. But I'm going to leave this up here. This is every cell we have in the body right here. Sodium on the outside, potassium on the inside. Same numbers of ions right there. It's called milliequivalents per liter. I don't need that right there. But we have negative ions trapped on the inside, negative ions, anions trapped on the inside of our cell. So every cell that we have right here has a negative potential difference. I want to go back to that axon just a few seconds. I'm going to draw and label that sucker again, okay? Draw and label that sucker again. I don't need this in your answer. I don't need this in your answer, but I got to go back to the axon itself. Okay? Back to the axon itself. All right. Now, go back in the 50s. There's a guy named Gurdon that was playing around with some amp meters and voltmeters right there, and he found a large sciatic nerve. Now, nerve is a group of axons. Excuse me. Well, it is a group of axons, but it's a group of neurons anyway. A nerve is multiple neurons grouped together. So he found one in a frog. It was from South America, a large sciatic nerve. Now, sciatic nerve runs about where your waistline is right here, down your leg. It helps you move your leg. And there's a condition for problems with sciatic nerve called sciatica. And it's a hellacious problem, okay? It hurts, all right? So anyway, this is my axon right here. This guy put a voltmeter right down in here, and he referenced it over here to a ground situation, and he found out that this thing read negative. This would be 0, this would be positive, this would be negative. So a single cell read negative. How can it be negative? Because the positive ions are equal on both sides of the membrane, but there are anions, negatively charged ions, on the inside of the membrane that are trapped. So we got to go back to this right here. Now I'm getting to your answer, okay? As far as being